Alright, this is how we're going to be doing this in a way that will make sure you get the best out of this course. What you must understand is the reason why we have a syllabus is so that you know exactly what the exam is going to contain. So our syllabus tells us exactly all the things we need to know in order to pass the exams, not only with a marginal mark but with 100%, because the syllabus tells it all. It tells the whole story. So to get the most out of this course, we will attempt every topic by first looking at what does the syllabus require us to do, and then work out all the questions that are related to the specific objectives of the syllabus. So to illustrate my point, let me show you what the syllabus for mathematics look like. So the syllabus for maths looks like this. Now, as you can see, in basic terms, these are the topics. Topic number 1, subdivided into A, B up to K. Topic number 2, topic 3, topic 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are a total of 12 topics. But the syllabus goes further to break down each topic into specific objectives. Now what you need to know here is all the specific objectives represent the questions that are asked in the exam. That's it. So if we are able to know each and every specific objective, then we are able to know everything in the exam before we even write it. Right? Is that cheating? No, it's not, but it is. So look at topic number 1 here. All you need to know is to define the different type of numbers, yeah? So we know natural numbers are all the numbers that are used in day-to-day usage. So in day-to-day, every day, you meet somebody, you talk to somebody, you go to the shop and everything, you deal with numbers 0 all the way up, depending on what you do. But in daily lives, you rarely talk about -1, -2, unless you're doing a mathematics topic. So natural numbers are simply numbers used in day-to-day usage. So it starts from 0 going all the way to the positive side. There's no limit. So it's numbers that are natural to use, yeah? And then we go to integers. Integers are simply all the whole numbers, whether they are positive or negative. So an integer is a complete whole number. So you cannot have 2.5, 2 1/4, 2.0, anything that is a portion does not count as an integer. It must be a full number. And then we go to rational numbers. All numbers, whether positive or negative, just like integers. And now here we also include rational fractions. And then we talk about rational numbers. So rational fractions, we're talking of 2 out of 5. We're talking of 1 over 4. All of those different numbers are what we call rational numbers. And then we continue, we go to irrational numbers. So irrational numbers are numbers that cannot be expressed as a fraction. Okay? So the easiest irrational number to illustrate is square root of 2. So if you want to see square root of 2, If I find square root of 2 in the calculator, you can see the answer is that. If I try to make it a fraction like that, it doesn't come out. Huh? Now, that is different from, say, a number like 5 divided by 8. Okay, if you do like that, it's a normal number and it's expressed as a fraction like that. So the easiest way of finding out whether a number is an irrational number is simply punch it in the calculator. If you see there is no pattern, then you know we are dealing with a rational number. There is no pattern. Okay? So no pattern here. And then we go to real numbers. Real numbers are all rational and irrational numbers. So as you can imagine, real numbers are all the numbers that we've discussed so far. It doesn't matter whether it can be expressed as a fraction, it can't be expressed as a fraction. As long as it is any number, it becomes a real number. Now, the next definition is very important because that's usually where your exam questions focus on, and that is a prime number. So a prime number is a number whose factors are 1 and itself only. What do we mean by this? We are saying a prime number is a number that cannot be divisible by any other number except itself and 1. So let's take a look at the number 2. The only numbers that can divide into 2 is 1. 1 goes into 2 times. And also 2. 2 goes into 2 once. So 2 is a prime number. That is the lowest prime number ever. You must remember that 1 itself is not a prime number. 1 itself is not a prime number. So we can go to another number, let's say 11. If you try to divide 11 by anything else, you will get a remainder. But if you divide only by 1 and 11 itself, then you can get no remainder. So is that true? Let's try it out. So if we try 11 divided by 2, you see we get a comma, so that's not how we want to divide a prime number. If we say 11 divided by 3, so you still get point something. So the only number that can divide into 11 is 11 itself, and it goes once and 1. That's why 11 is a prime number. So as long as a number cannot be divided by anything else other than itself and 1, it's a prime number. Very important on that one. And then we go to a reciprocal. So in day-to-day terms, reciprocal simply means I do something, you do something. You reciprocate. Yeah? I give you something, you give me something. I teach, you learn. I learn, you give comments. That's how a reciprocal relationship goes. With regards to numbers, however, reciprocal simply means you are converting the number to be opposite of what it was by simply adding a 1 on top of the existing number. You are adding 1 on top of the existing number and that number becomes a reciprocal. Let's say you have a number 2 and you want its reciprocal. So its reciprocal, like we said, you simply add 1 on top of the existing number. So we add 1 and then the existing number was 2. So that's a reciprocal of 2 is 1 and is half. What about if we had 3? We simply add 1 on top of 3 and it becomes 1 over 3. What about if we had 2 over 3? We simply add 1 on top of that and it becomes 1 over 2 over 3. When you simplify that, it simply becomes 3 over 2. So in other words, whenever you are finding the reciprocal of a fraction, simply switch the denominator and the numerator. So the denominator goes up, the numerator comes down. So it simply switches positions. So we go to another example. Let's say we had 1 over 4. The reciprocal, like we said, we switch. 4 comes here, 1 comes here. So in other words, it's simply 4 over 1, which is 4. That's how you get a reciprocal. And then we look at what is a factor. A factor is any number that would divide into another number without leaving a remainder. So let's take the number 4. What number can go into 4 without leaving a remainder? Obviously 1 can go into 4. 1 can go into 4 how many times? 4 times. So 4 is also a factor of 4. What else can go into 4? I think 2 can go into 4. 2 can go into 4 how many times? 2 times without leaving a remainder. So all those are what we call the factors of 4. All the numbers that can go inside 4 without leaving a remainder. They are factors of 4. And whenever you are writing factors, do not forget to include 1 and also the number itself. Like in this case, factors of 4, we included 1, we included 4, and we included 2. So 1 must be included, the number itself must be included, and any other numbers. Now, let's look at the highest common factor. The highest common factor, like in this case, sometimes a number is more than one factor. And you want to know what number goes into. Usually when you are given 2 numbers and you want to know what number can go into both numbers without leaving a remainder, but the highest of them. So the simplest example I'll give you is, I'll give you a number like 4 and a number like 8. So we know here 2 can go into 4 2 times. Also 2 can go into 4 once. So in other words, 4 is got factors 1, 2, and 4. What about 8? 2 can go into 8 4 times. 2 can go into 4 2 times. And 2 can go into 2 once. So 8, there is 1, there is 2, there is 4, and there is 8. So all these numbers can go into 8. They are all factors of 8. And 1, 2, 4 are all factors of 4. Now we want, what is common What number is common that can go into both 4 and 8 without leaving a remainder? So in our case, it's clear that 4 is common, 2 is also common, and 1 is also common. But we want the highest common factor. So if we are talking of highest, it means we only look at 4 and 4. So the highest common factor of 4 and 8, which means the number that goes in both 4 and also in 8 without leaving a remainder, is 4. Highest. Alright, we will use examples to illustrate more on how to calculate the highest common factor. In other words, what you must know, the highest common factor will always be either exactly equal or smaller than the given numbers. So in this case, you are given 4 and 8 and you want the highest common factor of those numbers. So our answer cannot be anything above 4, cannot be anything above 8. It has to be smaller than the given numbers or equal to the given numbers. Like in this case, our highest common factor is 4, which cannot be exceeding the smaller of the given numbers. Right, lastly, we look at the lowest common multiple. Now, common multiple, unlike common factor, is a number in which the given numbers can go into without leaving a remainder, the lowest of them. So I give our examples 4 and 8. So we're saying, what is the smallest number in which both 4 can go into and also 8 can go into it without leaving a remainder? So this one is pretty straightforward. We know our lowest common multiple is 8. Because 4 can go into 8 2 times and 8 can go into 8 once. But the question is, how did we get there? So when we work out lowest common multiple, we will illustrate these 2 points. Alright, we start on practice questions. T1A, it means topic 1, part A of topic 1. Number 1 says, list all the factors of the following numbers. So the easiest way of dealing with factors is simply come alright, we have a 6 there. We divide by the smallest number that we know that goes into 6 is 2. 6 divided by 2 we know equals to 3. So if we use 2, we get 3. If we use 3, we get 1. So when we rewrite, we know 1 is a factor, as you can see, 1 is there, followed by 2, followed by 3, and followed by 6. All of these are factors of 6. They said list all. So we list 1 and the number itself and anything else. How about 36? So 36, we start with 2 again. If you are not sure, please, the reason why this exam allows you to use a calculator is use it when you have to. So we start with 36 divided by 2. What do we get? 36 divided by 2 is 18. So we get 18. We try 2 again. 18 divided by 2. You get 9. So you get 9 here. And then, so we know the next number 2 will not go into 9 anymore. We try 3. 3 goes into 9 3 times. And we try 3 again. 3 goes into 3 once. Once you reach 1, then you know you are done with your factors. So let's list them down. So we have 1. We have 2. We have 3. And then we know if we multiply this and that, 2 times 2 we get a 4. So that will also be a factor. If we multiply this and that, we get 2 times 3, which is 6. That will also be a factor. If we multiply this and this, we get 9. That will also be a factor. And then we also have the 18 that we have here. And we have the 36 that we have here. So all the factors of 36 are 1, 2, 3, 4, 6, 9, 18, and 36. Alright. Does that look easy? We leave out all these ones for you to complete. Let's try number J. Alright, number J. We start with 100. We try with 2, you get a 50. You try another 2, you get a 25. So 2 cannot go into 25 without leaving a remainder. We try 5, you get 5. You try again 5, you get 1. So now we can write them down. Our factors are 1, 2, 3 will not work. We try 2 times 2, it gives us 4, so 4 is a factor. We go to 5, which is a factor. We try 2 times 5, it gives us 10, which is a factor. 5 times 5, it gives us 25, which is a factor. And then we have a 50, which is there. And then we have a 100, which is there. So all the factors of 100 are 1, 2, 3, 4, 5, 10, 25, 50, and 100. So that is the method that I recommend when you are looking for all the factors. If you have any questions, make sure to submit them via our WhatsApp group, and then we can attend to them. So I hope you attempt the remaining questions. Alright, part 2, list the prime factors. So it says prime factors Unlike the first question which said list factors, here it's only requiring prime. And then express them as a product of prime numbers. So let's start with 15. Whenever you are dealing with prime numbers and expressing as a product, this is how we do it. Just like we did with factors. We start with 15 here. We know 2 is not going to work, it's the smallest prime factor. 3 is also another prime factor, we try 3. 3 goes into 15 5 times. And then we try 5, it goes once. So the prime factors of 15 are 3 and 5. And now we want to write 15 as a product. Product means multiply. So we want to multiply the prime factors so that they give us 15. So we know 15 is equal to 3 multiplied by 5. That is expressing as a product of prime numbers because 3 and 5 are both prime. How about with attempt 24? Alright, 24. We try 2, you get 12. You try 2 again, you get 6. We try 2 again, we get 3. Now we try 3, we get 1. So, the prime factors of 24 are 2 and 3. Only the prime factors. Now we want to express 24 as a product of its prime factors. So 24 is equal to 2 times 2 times 2 times 3. There is 1, 2, 3 2's and a 3. If you want to write it in another way, you say 2, there are 3 of them, and multiply by 3, which is only 1. So that's how we express 24 as a product of its prime factors. So you must notice we were not asked to list all the factors, we were asked to list only prime factors. So prime factors are numbers that can be divisible by 1 and itself. That's why for 24 we only considered 2 and 3. Those are the prime factors. And then when we express as a product of its prime factors, it means we want to find 24 by using the prime factors. So we already know from our calculation that we have 2 2's and a 3. So if you try to punch that in a calculator, you should get 24. So 2 times 2 times, that's not a 2, times 2 times 2 times 3. As you can see, 2, 2, 2, 3. 2 times 2 times 2 times 3, you get 24. So that's expressing it as a product. So product times times times, that's the meaning of product. Alright. Let's try one more, which is 56. Alright, so we know 56, we try 2. If we try 2 in 56, 56 divided by 2, it's 28, you get 28. We try 2 again, you get 14. You try 2 again, you get 7, and then we try 7, you get 1. So the prime factors of 56 are only 2 and 7. Now we want to express 56 as a product of its prime numbers. So 56 is equal to 2 times 2 times 2 times 7. And we said if you don't want to repeat writing 2 and 2 and 2, you can say there are 3 of them, and there's only 1 7. And then that should be it. Expressing a number as a product of its prime factors. Is that clear? Alright. We go on to finding the highest common factor. So remember, we talked about common factors here. We want the highest common factor. So let's start with 8 and 12. So the easiest way of finding common factors is simply to express as a product of its prime factors and then find what is common. So how do we do that? We simply say, okay, we have our 8. We start with the smallest prime factor is 2. 2 goes into 8 4 times. We have 2 again. 2 goes into 4 2 times. We have 2 again. 2 goes into 2 once. So another way of writing 8 is to say 2 times 2 times 2. Alright, how about 12? We start with 2. 2 goes into 12 6 times. We go another 2. 2 goes into 6 3 times. And then we go to 3. 3 goes into 3 once. So another way of writing 12 is to say 2 times 2 times 3. Now, it's saying common. When something is common, it means it exists here as well as there. It's common. It's among everyone. So we want to see what is common in these numbers. So we know these 2 and these 2 are common. So to get our highest common factor, we know we have a 2, and we also have another 2 and another 2, so that's also common. Now we have a 2, we don't have another 2, so 2 is no longer common. We have a 3 and we don't have a 3, so our 3 is not common. So in other words, our highest common factor is simply 2 times 2, which is 4. Alright, let's attempt that. Let's attempt another question using the same method. let's use 12. Alright, 2 goes into 12 6 times, 2 goes into 6 3 times, 3 goes into 3 once. We come to 18. 2 goes into 18 9 times, 3 goes into 9 3 times, and 3 goes into 3 once. Then we go to 24. 2 goes into 24 12 times, 2 goes into 12 6 times, 2 goes into 6 3 times, 3 goes into 3 once. Now we rewrite. We know 12 is equal to 2 times 2 times 3. We know 18 equals to 2 times 3 times 3. And we know 24 equals to 2 times 2 times 2 times 3. Alright, from there we now look for what is common. So our highest common factor is, so we know 2, 2, 2, so 2 is common. 2, there is no more 2 here, so 2 is no longer common. 2 is no more there at 18, so 2 is no longer common, so we completely move away. We go to 3. We have a 3 here, we have a 3 here, and we have a 3 here. So 3. Do we still have a 3 in 12? No. We have a 3 again in 18, but we also still don't have a 3 in 24. So these are the only numbers that are common. A 2 is common and a 3 is common. So 2 times 3 gives you your highest common factor of 6. Isn't that easy to do? We do one last one. We start with 60. We try with 2. 2 into 60 is 30. 2 into 30 is 15. We go to 3. 3 into 15 is 5. We go to 5. 5 into 1, 5 is 1. Remember, we are using prime factors. All these ones are prime factors. For any of them, it's prime factors. Similarly, we do 144. We start with 2. Again, my point is, if you are not sure, use a calculator. 144 divided by 2. It's 72. We try 2 again. 72 divided by 2. 36. We try 2 again. We get 18. We try 2 again. We get 9. We try 3, we get 3. We try 3 again, we get 1. So once you reach 1, then you know you're done. So 60 can be written as 2 times 2 times 3 times 5. And 144 can be written as 2 times 2 times 2 times 2 times 3 times 3. Now we look for what is common. So our highest common factor is, so 2 and 2 are common. Nice. Another 2 and another 2 are common. Nice. There is no more 2. So we go to 3. So 3 and 3 are common. There's no more 3 in 60. We try 5. There's no 5 here. So only these are common. So 2 times 2 times 3 gives you 12. That's your highest common factor of 60 and 144. Alright, that should be it. You attempt the remaining questions, yeah, for highest common factor. Now, we look for the lowest common multiple. So it's LCM. The procedure for getting highest common factor and for getting lowest common multiple is exactly the same, but it differs only at the end. So let's do this with an example. Alright, so if we say the procedure is the same, it means the first thing is to break down as a product of its prime factors. So we start with 8. We try 2, we know 4 times. We try another 2, we know 2 times. We try another 2, we know it's once. And then we go to 12. We try 2, we get 6. We try 2, you get 3. And then we try 3, we get 1. Alright, so let's rewrite. We have 8 equals to 2 times 2 times 2. And then 12 is 2 times 2 times 3. Alright, let's look for our lowest common multiple. We start with 2's. So with lowest common multiple, unlike highest common factor, where we were looking for what is common, here we take each and every prime number and we choose in which number does it appear the most. So we're going to include each and every prime number and where it appears the most. That's what we want. Okay, so let's illustrate that. So we start with 2. You see there is 2 2's at 8, and how many are there? There are 3. And there are also 2's on 12, and how many are there? There are only 2. So we know 2's are most in this zone, and there are 3 of them. And then we go to 3. There is no 3 here on 8, but there is a 3 here on 12. And how many are there in 12? It's only 1. So that will give us our lowest common multiple, which is 2 to the power of 3 times 3 to the power of 1. So our lowest common multiple is 24. And remember, we said lowest common multiple is a number in which both of the given numbers go into without leaving a remainder. Alright, I think to illustrate the point better of lowest common multiple, we attempt C and H. Or maybe C and D. We start with 25. We know 2 doesn't work, 3 doesn't work, so we start with 5. 5 goes there 5 times, and then 5 goes there once. We go to the next, which is 40. We try 2, it goes 20 times. We try 2, it goes 10 times. We try 2, it goes 5 times. And we try 5, it goes once. And then lastly, we try 100. We start with 2, it's 50 times. We try another 2, it's 25. We try 5, it's 5. We try 5, it's once. So we rewrite everything. We know 25 is 5 times 5. We know 40 is 2 times 2 times 2 times 5. And we know 100 is 2 times 2 times 5 times 5. Alright, like we said, lowest common multiple. We include each and every prime factor. So our prime factors here, it's only 2 and 5. But we want to include where they are the highest among the numbers. So let's start with 2. So 2 appears the most under 40 there. How many times? 3 times. Because in 40 we have 2 times 2 times 2, 3 times. So it's 2 to the power 3. And then the next prime number is 5. 5 appears in 25 2 times, in 40 only once, in 100 2 times. So we know the highest is 2 times. So it's 5 to the power 2. So that should give us our lowest common multiple, which is 2 to the power of 3 times 5 to the power of 2. So our lowest common multiple is 200. Right? Like we said, we will be generous, so we'll do one last one. We start with 12. We have 2 6 times, 2 3 times, 3 once. We go to 18. We start with 2, it's 9. 3, it's 3. 3, it's 1. And then we go to 24. Start with 2, 12, 2, 6, 2, 3, 3, 1. We rewrite 12 is 2 times 2 times 3. 18 is 2 times 3 times 3. And then 24 is 2 times 2 times 2 times 3. Remember, we said LCM, we include each and every prime factor. So we start with 2. Where does 2 appear the most? In 24, it appears 1, 2, 3 times. So to the power 3. We go to 3. Where does 3 appear the most? In 18, it appears 1, 2 times. No other prime factor exists. So our final answer is 2 to the power 3 times 3 to the power 2. So it is 72. So your LCM is 72. Very easy stuff. Alright. We worked on reciprocals as part of our definitions, and we said a reciprocal is simply switching the numerator and the denominator of a number. Okay, so the first thing to do is to make the number vulgar, meaning if you have a mixed number or a decimal, please rewrite it as a vulgar fraction. A vulgar fraction has got a big denominator on top and a small number at the bottom. That's a vulgar function. So let's start with 1.5. So 1 and 1 over 2, we convert it to vulgar. Remember, we say 2 times 1, and then we multiply going here and we add going here. So 2 times 1, which is 2 plus 1, which is 3. So it is 3 over 2, right? Now to make it a reciprocal, remember we just switch. This one comes here, this one comes there. So your final answer is 2 out of 3. 1 over 6. This one comes here, this one goes there. So it's simply 6 over 1, which is 6. 3 and 2 over 5. First thing is to make it a vulgar fraction. So 3 times 5, or 5 times 3, it's 15. 15 plus 2, 5 times 3, 15 plus 2, 17. So 17 over 5. Now this one comes there, this one goes there. So it's 5 over 17. Alright, what about 70? So for a number which is simple like this, we simply add a 1 on top. So it becomes 1 over 70. That's how we find the reciprocals of all of these numbers. So bonus, 5 over 6, this one comes there, this one goes there. So it will be 6 over 5. Very simple, getting the reciprocal. Next, for each of the numbers, state whether it is rational or irrational. So we said any number that does not make sense, in other words, does not have a pattern, is irrational. Everything else is rational. So obviously 1.6, there is a simple pattern there, which is just 1.6. So it's a rational number. 0.8, simple as well. It's straightforward. It's just a rational number. Root 36, we said we just use a calculator and see if there is any funny things. There is no funny things. Root of 36 is 6, so it is also a rational number. How about negative 5 and 4 over 9? So already, so on our calculator we have a shift and we put that sign. So negative 5 and we have a 4 and we have a 9. So if we come and put here, there is a pattern, as you can see, negative 5.4444444. That's a simple, straightforward pattern. So it is a rational number. can have a pattern of 4s in your head. How about square root of 11? Square root of 11. Alright, look at that. 3.3162479. There is no pattern here. It goes on and on and on and on and on, changing different numbers. That is a typical example of an irrational number. There is no pattern that is being formed by whether you divide, whether you put it as a decimal fraction. That's why we know that 11 is an irrational number. How about 5 plus square root of 16 minus 4? So, you simply come and 5 plus bracket square root of 16, move again, minus 4. Right, there you go. Your answer is 5. 5 is a number that is pure, so it is a rational number. 0.22 and those dots on top simply means 2 is repeating itself. So that is also a very rational number. Whenever we have dot, it means that number is repeating. So it means it's 0.22, 22, 22, 22, 22, going on like that. Alright. So that's what these dots represent here. So if we have 0.7 dot there, it means 0.7777. So there is a pattern. So all of this is a rational numbers. Alright, we do the last one, h. Root 10 divided by root 3. So again, we simply use a calculator. Fraction root 10 divided by root 3. 1.825741858911. It goes on and on without a pattern. That is an irrational number. There is no pattern there. It just goes on and on and on and on. So that's typical of an irrational number. So that is it, guys. Rational, simple, there's a pattern, or there's just a normal fixed number. Irrational, no pattern, just random numbers coming up and again and again. Only that our calculator can only display certain numbers. If it was going to go continuously, it was going to be just random numbers going on and on and on. So that's how we know we have an irrational number. So that is it for topic 1A of our syllabus. Just to recap, these are the objectives of topic 1A. See you in the next topic, and let's keep strong. We can do this. Namibia Senior Secondary Certificate of Ordinary Level Grade 11 Final Exam. All the way to the top. 100%. 100. 100. 100. 100. Ciao.